Hi, welcome to Easy BTech channel. Myself Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I am discussing about the what is the power factor equation in three-phase circuit by using two wattmeter method. That is, in three-phase circuit, the total power can be calculated by using only two wattmeters. That means in any two phases, two wattmeters are connected, then the total power will be calculated. For us, suppose I am considering the star connected load. The star connected load, that is, this is R phase. The first phase is R phase. In that R phase, I am connecting one wattmeter. We know wattmeter consists of two coils. One is current coil and another one is pressure coil. This is current coil and this is pressure coil, and also this is phase B, and the third one phase C. In phase Y, in phase Y also another second wattmeter is connected. That is, in R phase, in Y phase, two wattmeters are connected, pressure coil here, and the connection of the pressure coil is, that is, the pressure coil in two wattmeters are connected to another phase. That is, the pressure coil of second phase is joining with phase B, and the pressure coil of first wattmeter. So this is called wattmeter 1, and this is pressure coil of second wattmeter. This is called W2. For example, the W1 wattmeter connected in R phase, W2 wattmeter connected in Y phase, but the pressure coil of two wattmeters are joined remaining phase. That is, the remaining left phase is only B. That is, the pressure coils of two wattmeters are joined with phase B. Hence, the current passing through R phase is IR. The current passing through Y phase is IY. And the pressure coil W1 connected between R and B. Then the voltage is VYB. And W2 pressure coil is connected between Y and B. Then the voltage is VYB. Okay, that is, the reading of wattmeter shows, we know what is the formula for power here, that is V I cos phi. Nothing but that is W1. W1 is the wattmeter connected in R phase. Then the voltage is VRB. The passing current is IR. Let the phase angle is phi 1. Okay. The angle phi 1 is the phase angle difference between VRB and IR. Similarly, the wattmeter reading for W2 is, that is VYB into IY into cos phi 2. Here, the angle phi 2 is the phase angle difference between VYB and IY. So, these are the readings of the two wattmeters. So, based on the voltages connections, then you draw the phasor diagram of two wattmeter method. We know that is VR voltage and second one is VY voltage and third one is VB voltage. We know that. Then here what is the voltage reading of W1, that is VRB. That means the opposite of VB is nothing but minus VB vector. Hence the voltage is nothing but VRB, that is connection of both vectors, that is VR equal to VRB equal to VR minus VB. Okay, here what is the angles here? That means what is the current here? Let us consider the current passing through W1 wattmeter is IR. Then what is the angle between VR and IR? That between voltage and current, we know the phase angle, consider phi. Consider that. Then in star connection, what is the voltage angle between the phase voltage and line voltage? Is nothing but plus 30 degrees. Then what about remaining angle? We require the angle between IR and VRB. Why? Why? Because these are the quantities reading by the wattmeter, VRB and IR. Then total angle is 30, remaining angle is 5. Then what about the angle between IR and VRB? That is, this angle is 30 degrees minus 5. Okay, this is the angle difference between IR and VRB. Similarly, if you find out other voltage, that is wattmeter reading VYB. Similarly, this is connection of this vector and this vector, that is VY minus VB. The same manner we can write down the current also. Then this is the current IY. We know the phase angle is phi. And what is the angle between phase voltage and line voltage? We know that is 30 degrees. But we require the angle between IY and VYB. That is the total phase angle between IY and VYB. That is 30 plus 5. Okay, here the important point is the two angles. What is the angle between IR and VRB? What is the angle between IY and VYB? Why? Because that is IR W1 reads the values of IR and VRB. That's why we require what is the angle between the IR and VRB. Similarly, W2 reads IY and VYB. That's why we require what is the angle difference between IY and VYB. That's why in phasor diagram we have to calculate the angle between the quantities. Okay, that is 30 minus 5 one angle, 30 plus 5 one angle. Okay, according to phasor diagram we can derive our required power factor equation. That is, we know what is the reading of wattmeter 1, that is W1, that is VRB IR cos of angle between VRB and IR. From the phasor diagram, the angle is 30 minus 5. Okay, then we can change into in the form of line quantities, that is root 3 VRB nothing but phase and IL cos 30 minus 5. That means VL IL cos 30 minus 5. Okay, we know VL equal to root 3 into VPH. Similarly, the reading of W2 is also VYB IY into what is the angle here? Cos 30 plus 5. That is the reading of W2 wattmeter. Then similarly we know same in the format, that is VL IL cos 30 plus 5. Okay, this is the angle difference is there. Or in the form of, you can find out same root 3 VPH IPH cos 30 plus 5. Okay, then from the readings of W1 and W2, we can derive our required quantities. That is required equation of the power factor. First of all, that is case 1. You can find out what is the condition of adding of two wattmeter readings. That is W1 plus W2. You have to find out W1 plus W2. What is the reading of W1? That is root 3 VPH IPH cos of 30 minus 5 plus what is the reading of W2? Root 3 VPH IPH cos of 30 plus 5. Hence, what is the common term here? Root 3 VPH IPH cos of 30 minus 5 plus cos of 30 plus 5. Okay, here, what is the formation here? In the bracket term, we have cos of A minus B plus cos of A plus B. That is cos A minus B plus cos A plus B. The formula is 2 cos A cos B. That is root 3 VPH IPH, then 2 into cos of cos A cos B. We know the value of cos 30 is nothing but root 3 by 2. Then 2 is cancelled, that is root 3 into root 3, that is number 3 will get. Then total power we will get here 3 into VPH IPH cos 5. So that is the total power by using 2 wattmeter method is adding of the readings of the 2 meters. Then you will get total power in the 3-phase circuits. 3 into VPH IPH cos of 5. In the same manner, you can convert into line values also, that is root 3 into VL IL cos of 5 in the form of line quantities. Similarly, case 2. We have to find out what is the difference between two wattmeter readings. In the same manner, that is you have to find out W1 minus W2. Then common the term here root 3 VPH IPH cos of 30 minus 5 minus cos of 30 plus 5. Okay, you will consider W1 minus W2. Then what is the in bracket term here? Cos of A minus B minus cos A plus B. Okay, that is, you have to find a difference. You will get 2 sin A sin B. Then root 3 into VPH and IPH. Then 2 into sin A sin B. We know the value of sin 30 is 1 by 2. Then 2 will be cancelled. Hence, the reading is root 3 into VPH IPH sin 5. That is the reading of W1 minus W2. Then on both sides you will multiply with root 3. Then to get 3 into VPH IPH sin 5. Then change into line values, root 3 into VL IL sin 5. That is the W1 minus W2. Okay. Then you can divide both equations. That is, divide W1 plus W2 and W1 minus W2. That means we have to consider root 3 into W1 minus W2 by W1 plus W2. Take division between the two equations. That is second equation by the first equation. What is the difference equation? We will get here root 3 VL IL sin 5. What is the equation for addition? Root 3 VL IL cos 5. Then root 3 VL IL, root 3 VL IL cancel. Sin 5 by cos 5. Then we will get tan 5. Okay. From that, you have to find out the angle phi. That equal to tan inverse of root 3 into W1 minus W2 by W1 plus W2. So this is the equation of the power factor angle in 2 wattmeter method. That is phi equal to tan inverse of root 3 into W1 minus W2. This equation is very most important. There is compulsory problem in GATE examination also. Okay, after that, finding the value of phi, then we have to find out the angle of cos phi. Then cos phi equal to, apply cos to the equation, cos of tan inverse of W1 minus W2 by W1 plus W2. So this is for lagging equation. There is a lagging power factor. If the power factor is leading, then what happened? That is for leading power factor. Same for leading factor. For leading power factor, the phase angle becomes, that is phi equal to tan inverse of minus root 3 W1 minus W2 by W1 plus W2. That is, inside tan we can mention minus, which is equation for leading power factor. Okay, most in the problems, most probably the values are given for lagging power factor. Okay, like that we can find out the power factor angle when the readings of both wattmeters we know, that is W1 and W2 readings are given. Then we will find out the power factor angle phi. After that we will find out the power factor cos phi. From above equation, that is after we know the equation of power factor, then if the power factor is changed, that is effect of change in power factor, that is if the power factor value will be changes, then what happened to the wattmeter readings? Okay, how the readings will be changes according to the value of the power factor. For example, consider, that is we know, first of all we know, that is the readings of W1 is nothing but root 3 into VPH IPH cos of 30 minus 5. W2 equal to root 3 VPH IPH cos of 30 plus 5. We know the readings of wattmeter. Then from that equation, if the power factor will be changes, then what happened to the readings? That is, in the first case, if the power factor is unity, that is cos phi value is 1, from that phi value equal to 0, then what happened? W1 value, that is cos 30 root 3 VPH IPH cos 30. Similarly, W2 value root 3 VPH IPH, then cos 30. That is, both equations are same when unity power factor. That is, power factor angle is 0. That is, both readings are equal. What is the meaning that here? That means both readings, both wattmeters shows equal and positive values. Okay, now when power factor angle is 0, that is unity power factor, both power factors represent or gives positive and equal values. Similarly, in the second case, when power factor is 0.5, power factor value is 0.5, that is 1 by 2. From that, the angle is, power factor angle is 60 degrees. That's why, what is the reading of W1 root 3 VPH IPH cos of 30 minus 5, that is 30 minus 60, 30 degrees. Cos of minus theta, cos theta. Similarly, W2 equal to root 3 into VPH IPH cos 30 plus 60 cos 90 degrees. You know the value of cos 90 is 0. That's why the reading of W2 is 0. That is, the reading of cos 90 is 0. That's why the reading of W2 meter is 0 when the power factor is 0.5, that is 1 by 2. That means in this case, one of the wattmeter reading is 0. Okay, any one of the meter shows 0 reading when power factor is 0.5, 1 by 2. Similarly, in the third case, if power factor angle is cos 90, that means power factor is 0. Then what is the reading of W1 root 3 VPH IPH cos 30 minus 5, that is cos 60. Similarly, W2 equal to root 3 into VPH IPH cos of 30 plus 5, 30 plus 90, 120. Cos 120 equal to 90 plus 30. Okay, that is cos of 120 degrees. This cos 120 degrees, we have to write down cos of 90 plus 30. Okay, that is cos of 90 plus theta, we will get sin theta, that is minus sin 30. Okay, that is minus sin 30 value. Then what is the meaning here? The W2 shows the reading is negative. That means both values are equal. Cos 60 or sin 30, the values are equal. That's why, but the readings are in opposite. That means the readings are equal, but opposite. Opposite means one meter shows positive value, another meter shows negative value. That is, one meter represent gives positive power, another meter gives negative power. Okay, when the power factor angle is 90 degrees. Okay, like that we have to find out the power factor phi tan inverse of root 3 into W1 minus W2 by W1 plus W2. Please subscribe our channel and share to your friends.